Hello everyone, welcome to Study Made Easy, a smart learning for a smartphone generation. Now, in this video, we'll be continuing our discussion on sets, and in this video, I am going to talk about subsets. Right? Now, what is a subset? Now, to explain this, let me consider two sets. Let me say I have a set A, and that contains students of your school. We have students of your school. Now consider another set B, which contains students of your class. Right? Now if you notice that every student of your class is also the students of your school, right? So I can say that every element of B will automatically be present in A, right? Now if this condition follows, that if every element of B is also in A, we say that B is a subset of A, right? We say B is a subset of A. Now here you can see that A is a major set here, right? And B is a minor set. Now what does this mean? Now by major set I mean that it will contain more elements than B. Let me give another example. Let me say we have a set A and it contains an element of A, B, C, D, and we have a set B which contains elements C and D. Now see here, now this contains more element than this, right? And number second, every element of B is also present in A. So in this way I can say that B is a subset of A. That means B has been derived from A. You got me? So this is what we mean subset. Now this is the mathematical representation of subset, and in this you can say that every element, let me write this now, every element of B is in A, right? Now this is what we mean as subset. Now if you see that phi, which is also called as null set, right? Now null set is a subset of every set, right? Now null set is also a subset of A. Null set is also a subset of B. So null set is a set that is, null set is a subset of every set. I hope you got this point. Now let's move and let us talk about a new thing, and that is intervals of subsets. Let's talk about intervals. Right. Now basically if I talk in broad perspective, we have two types of intervals. One is the open interval and the second one is the closed interval. right? We also have semi-open interval. We'll talk about that also. But what do we mean by open interval, right? Now, let me take an example. Now, open interval is written by this. You have elements here and it is written like this, and closed interval is written like this, and you have elements between them. Let me give you an example. Let me consider a set in a set builder form, and let me write that set x such that x belongs to R, and we have -5 is greater than equal to x and it is less than equal to 7, right? Now you can see here there is two equality signs here, right? Here and here. So this is written as like this. By close interval, we mean that you have to include both -5 and 7 and also the elements which come in between -5 and 7, right? So I will again repeat that by closed interval, we mean that you have to take both the extreme ones, -5 and -7, and you have also to take the elements that are in between -5 and -7. Now, if I rewrite this, if I modify this example, let me say we have x such that x belongs to R, we have -5, we have this. Let me say we have this. Now, you have no equality sign here. That means you can't, x has to be greater than -5 and x has to be less than 7. So you can't take -5 and 7 in this one, right? So you will write it as -5, 7, which by this open interval, you mean that you can't take -5 and 7, but you will take the elements which are in between them, but you will leave the extreme ones, right? Let me say I have another example, x such that x belongs to R, and let me say I have something like this. Now here you can see that x has to be greater than or equal to -5 and it has to be less than 7. So what does this mean? Since -5 contains an equality sign, you will put an closed interval and then you will write -5. But since 7 doesn't contain an equality sign, so it has to be an open interval. So it can be written like this, right? Now similarly, if you have like this, now this can be written as -5, 7, right? Now this is what we mean by open intervals and closed intervals, and these two are actually semi-open intervals, or you can say semi-closed intervals, whatever you like, right? I hope you get this. Now next what we want to talk about is that let's talk about power sets. What do we mean by power sets? So let's move and talk about power sets. Now sometimes in a question you are told to calculate the number of subsets that can be generated from a particular set. Let me say I have a set A and it contains an element 1, 2. Now if you are being told to calculate the number of subsets of A, how will you do that? The power of set can be written as P of A, and the general formula for calculating the number of subsets that can be generated from a particular set is actually 2 raised power n. right? Where n is the number of elements. Number of elements, right? Now let me take this example. Now the thing that I forgot to tell you in subset is that every element, or I can say every set, is a subset of itself. So if I have a set, let me say B, and it contains 1 comma 2 comma 3, it will contain subsets as 1, another subset that will it contain will be 2, another subset that will be 3, and so on. But 1 comma 2 comma 3 will also be a subset of B. So every set is a subset of itself, right? So if I take this example, let us see how many subsets can be generated from this set. Now we have the first subset that can be generated is 5, because I told you that null set is a subset of every set. And this second subset that can be generated from the set A will be 1. The second will be 2. And since every set is a subset of itself, so there will be 4 subsets, right? And if you put 2 here, because 2 means number of elements, it will also be equal to 4. So I hope you have got this. Now this is what we mean by power of sets. Now I think this is enough for this video. I'll see you in the next video. Till then, take care and study smart.